a PowerPoint already. So we are in the example of mixed ANOVA. Okay, before that is this one, all right? Okay, so let me repeat again for a better understanding. Okay, researcher would like to know whether any significant effect on fitness score after a 3-month vigorous exercise training among adult study participants. And researcher conducted a randomized control trial where participants were randomly assigned to intervention and control group. The intervention group undergone 3-month vigorous exercise training and the control group undergone regular exercise without training given. So the fitness score was measured for all participants in both groups before intervention program starts, and then measured again at the end of first month, and then at the end of second month, and at the end of third month, which is the post-intervention. So the fitness score is ranged from 0 to 20. So higher score indicate better fitness level. So this example is similar with the example given in the repeated measure ANOVA. Okay, just added the group variable. The group variable is the control group. So now we have intervention and control group. So for this exercise, you can use exercise intervention underscore control.sme. Okay. So the research question we can ask, okay, you may use this or modify this sentence and then use it in your proposal or in your dissertation. So you can ask, is there any significant difference of mean fitness score within group based on time? So we want to know whether the fitness score is different or not for intervention and for control group within the group. So this is within subject design, so within group factors, or we call it the time effect. So the second research question we can ask, is there any significant difference of mean fitness score between group regardless of times? Because we have group variable, we have intervention and control group, so researchers definitely want to know, is there any difference between these two groups or not, regardless of times. So this is between subject design or group factors regardless of time, or we call it intervention effect, overall, and group effect. So the third question we need to ask is the interaction effect. So is there any significant difference of mean fitness score between or among group with regard to times? So this is within between design, so between group factor with regard to time. So means that at time 1, is there any difference between the group or not? At time 2, is there any difference between these two groups or not, and so on? Okay, so that would be the interaction effect. So the data set will look like this. If you open the data set already, you notice that additional column, which is the group column. So two groups we repeatedly measure on the fitness score. We have the fitness score from time 1 to time 4. And then we have the grouping variable, which is intervention and control. Yeah, so look back at the step again. We have 4 steps here. But step 3, we have additional assumption. We need to check which is homogeneity of variance and covariance. So when there is a group factor, then we need to check the variance and covariance. So because we want to make sure the variance and covariance between the two groups is almost the same. If it is different, so it means that there might be some bias for the result given in the SPSS later on. So we need to be aware of it, that if the assumption is not met, then we have to discuss it as a limitations. Okay, type of data used in here, we have the fitness score in our data set. Okay, the fitness score at time 1, time 2, time 3, and time 4. And then we have the group variable or the group column in our SPSS, which is the intervention and control group. Okay, then we do the analysis, go to analyze, go to general linear model, and choose repeated measure again. Okay, so here we move the time variable into the within subject variable. So this is the fitness score at time 1, time 2, time 3, and time 4. And then we also have another group variable, right? So you move the group variable into between subject factors. Okay. Sometimes your supervisor might ask you to control certain covariate, for example, age. Okay, age might have an impact on the fitness score. So you can include the age into, put the age under this covariate box. Covariate is for numerical variables only. So your confounding variable should be a numerical in this case. Okay, this is optional. Okay. So you do the same analysis. First thing you have to check is the multi-test of sphericity. So again, in here, you get a p-value which is significance. So based on multi-test of sphericity, the p-value is 0.003, which is significant. So it means that the assumption of compound symmetry is not met. So you can report the multivariate test or test of in-subject effect, the Winghouse guesser, or the Hung-Fan value, the F statistic value. So if you take the result from the multivariate test table, so you can choose whether to report the P-right trace or with lambda here. So this is the time effect. Time effect is significance. Time effect is significance. Okay, so when the p-value for time effect is significant, so the analysis will be followed by one-way repeated measure ANOVA with pairwise comparison on time within each group. So if this is significant, means that there is a significant changes from time 1 to time 2, but we do not know this happen in which group. Is it happen in intervention group or happen in control group? So we have to do the pairwise comparison separately for intervention and control group. Okay, so I will show you how to do it. Okay. So we in SPSS we can do the select cases. Okay, we want to do the analysis for group 1 only for the intervention group. So you can go to select cases, okay, in the SPSS, and then if condition is satisfied, you click this if, and then you in the group you select group and move it to here, and then choose equal to 1. So it means that in the next analysis, SPSS will do analysis for group 1 for the intervention group. So intervention group is labeled as 1 in this data set. So click continue, okay, then you will see your data set, your SPSS data set. Here you see that the SPSS has already filtered out the data. So in the next analysis, okay, SPSS will do for group 1 only, group 1, which is interventions. Okay, after we have complete the pairwise comparison for group 1, then you can do the same thing, select cases for group 0, and run the pairwise comparison analysis again for group control group. Okay, so you notice that this filter with a dollar signs. If let's say you want to remove, you want SPSS to do analysis for all the subjects, you can just select or highlight this filter dollar sign and remove it or delete. Okay, in your keyboard, click delete. So this will disappear. Okay. This slash means that SPSS will not do the analysis on data from 13 to 24. So if remember when you do select cases, once you have complete the analysis that you need to make sure you have to make this disappear. Otherwise, you found that the result will be very weird after that. Then you notice that, my data set is only include the intervention data set. So how to make this disappear? You just, highlight this filter dollar sign and select delete in your keyboard. On. So because we choose group 1 only, so that in the next repeated measure analysis, we won't have between subject factors here. Because we select to do repeated measure on group 1. Okay, because we want to do pairwise comparison for group 1 only, pairwise comparison for time 1 until time 4. So here you don't have the group variable, so you must remove it. Then in subject variable, you have time 1, time 2, time 3, and time 4. And then you choose estimate marginal means here. And then choose, put this time into display mean for. And then choose Bofroni, click continue, click OK. And then go to the SPSS output. Okay, you get the table that you need. So this is the mean for each time for intervention group only. Okay, so this is a pairwise comparison for intervention group, time 1, time 2, and what is the result? Okay, so after this, you have to do the same thing for control group. Using the same method, select cases, select control group, and do the same analysis again, and you get this mean for each time point for control group, and also the pairwise comparison using Bofroni for control group at time 1 versus time 2, time 1 versus time 3, and so on. So you see that there is a difference between the mean difference for intervention and control group. So here for control group, we notice that there's no significant difference from time 1 to time 2. The p-value is more than 0.05. From time 1 to time 3, yes, there is a significant difference. P-value is 0.024. And from time 1 to time 4, yes, there is a significant difference. Okay, if you want to look at whether any difference between time 2 and time 3 in the middle of the intervention, so there's no difference. So here you will notice that which time point or which comparison on time is significant. Okay, so you also can further interpret and write the story of this result. So you can say for control group, significant difference was observed between pre-intervention and end of month 2, pre-intervention and end of month 3. So other pair comparison was not significantly different. Yeah, because we only have 2, right? Only got 2 significant. Okay, so next is we want to look at, now time effect we know already, time effect is significance. Okay, for intervention group, all the pairwise comparison for the time is significant. For the control group, so only 2 pairwise comparison for the time is significant. So the time effect we have already settled. So now we move on to the group effect. Remember, the group effect is for your second research question or your second research objective. So where to find the group effect? So you can look for the S or between subject effect table and look for this group variable, and the F statistic is 53, which we should report in the table, and then the p-value is significant. So this means that there is a significant difference of fitness score between group regardless of times, and report the F statistic degree of freedom value. So the degree of freedom is 1,22, include the error. Okay, next. So the group effect we already settled. Now the third question is what? Remember, the third question is what? The third question is the interaction effect. Oh, haven't go into. There's another thing I want to show you before we move on to interaction effect. Okay, here we know that the group is significantly different, right? But for reader or for your examiner, they might want to know what is the value of the difference. Okay, so you can get this value by selecting this option, estimate marginal means, and then choose all of them, group time and plus the group start time. This is interactions, and move it under display mean for all these, and then select complement effect, which is more Bofroni. Click continue and click OK, and then you'll be able to get this estimate value for control group and intervention group. So this is the overall group mean fitness score, okay, for control and intervention regardless of time. And this is the pairwise comparison for control interventions. So overall, there is a difference between control and intervention group, and the mean difference is 5.375. This is the fitness score unit. And then the p-value is less than 0.05, and we also have the 95% CI. So overall mean group fitness score difference is significant. Okay. Okay, if you have 3 groups or more than 3 groups, right, you should proceed to post-hoc test. Proceed to post-hoc multiple comparison if there are 3 or more groups. Okay, so if let's say your study involves 3 groups, sometimes in experiment you have like using different dose, right? Like 10 ml, 20 ml, and 30 ml. So there are different group with different measurement or measuring differently. So you have to proceed with post-hoc test to find out which group is different from which group. But in this exercise, we only have 2 groups, so we don't need to proceed with post-hoc. If there's a difference, means that these 2 groups is different. Okay? So next question that we need to get the answer is the interaction effect. So the interaction effect, you can look at this time star group. Okay, so interaction effect is significant here. So all the statistic methods provided here consistently suggest that there is a significant interaction effect. So when the p-value for interaction effect is significant, so analysis will be followed by producing adjusted mean with 95% confidence interval. Okay, how to get this one? Okay, this is not produced automatically from SPSS. So today you're going to learn another knowledge. Okay, SPSS actually you can use SPSS by clicking the thing that you want and then you get the output you need. Okay, but you also can write your own syntax in SPSS. For those who have interest in writing the syntax, you can use the syntax to run your analysis. Okay, where to find the syntax? Actually, is this one, test. Okay, so we have this option selected, and then continue, and then we click test. So when you click test, it will direct you to another view, which we call it syntax SPSS, and you see this. So this is syntax when we're doing the coding and we do the analysis. So we have to do a bit of editing on the syntax in order to get, the comparison between intervention and control at time 1, time 2, time 3, and time 4 separately. Because this is not produced automatically by the SPSS when you do the normal clicking. So we have to do this very simple syntax editing. So you just add this command, compare group and ADJ, so adjusted using Bonferroni. Okay, and then after that you select all that and you click this one, the triangle, highlight all and click run selection. So run the selection, go to SPSS output, and then you should be able to get this table. So this is the table we want when your interaction effect is significant. Okay, this is estimate value for time 1, time 2, time 3, time 4 for control intervention group, and following by these pairwise comparisons. Okay, whether any difference between control and intervention group at time 1. So what is the mean difference? So we know that at time 1 there's no difference, right? The mean difference is almost 0, and the p-value is not significant, it's near to 1. And then at time 2, this is very good news because normally we want the baseline data to be equal. We want our baseline data to be no difference. Everyone start at the same level. So it means that the fitness score is almost the same for both groups. Okay, so this is normally a very common question by examiner. Did you check your baseline data? Are these 2 groups equal or almost similar when before the intervention start? Okay, so this is what we prefer to have. If you didn't get a result like this, if it says significance, of course you can justify. Yes. Okay, if you want to ask a question, you can unmute. If not, then remember to mute your mic. Okay, so at time 2, we have control group and intervention group, and then the p-value is significant, and the difference between these two groups at time 2 is 4.167. Okay, why it is negative? Then you will know that the control group have the smaller fitness score compared to intervention group at time 2. So that's why control minus intervention is negative. Smaller value minus bigger value is negative. So this is positive because intervention group fitness score is higher than the control group. So that's why here doesn't have negative. So you just report one of them, either the negative one or the positive one. Okay, so move on to time 3. That is the difference between the two groups. P-value is significant. And move on to time 4. Yes. Okay. So next is we want to get the plot, right? We want to see how the changes look like by observing the plot. So you go to plot, okay, and then your horizontal axis will be the times, and then your separate line will be the group, and then you click add, and then you appear under this box, and then click continue, click OK, and you will get this graph. So this graph, this one is the intervention group, and the blue line is the control group. So here you can see that at the starting point, both groups are homogeneous or they are equal. And then you can see that the control group increased as well in the fitness score, but the increment is more obvious for the intervention group. Okay. Okay. After this, step 2, we have already done it. We have already find the result for time effect. We already got the result for group effect, and we also got the result for interaction effect. So next is we want to check the assumption for this model, okay, for this mixed ANOVA model, whether it match or not match. Okay, so in here we further proceed to this click save, and request for the residual. So you get the residual. Okay. I accidentally, I think I clicked the unstandardized predicted value as well. Actually, this one you no need to click. So you just need the residual unstandardized. If you click the unstandardized predicted value, you get this 4 column here. But just ignore this 4 column. Don't follow me. You just need the residual value. You need this 4 column residual value for time 1, time 2, time 3, and time 4. Remember, you need this value to plot histogram to see whether the residual is normal or skewed. Because the assumption for the residual is normal. Okay, so we plot the histogram. So for the residual for time 1 is quite normal, so it's okay. For time 2 is okay also. For time 3, okay. For time 4, also okay. So all the residual are normally distributed or approximately to normal distributed. So the assumption for this, for normality of residual is met. Okay. So we move on to the homogeneity of variance and covariance because we have grouping variable. So that is an assumption we need to check whether it fulfill or not, which is the variance and covariance. So this is when you have grouping variable. Okay, in the option, you can choose homogeneity test and then click continue and then click OK. So look for this table, Levin test of equality. So you have this p-value. So as long as the p-value is I think this one it moved down. It should be based on mean. Okay, it should based on mean. This box should be selecting based on mean, similar with others. Okay. So all are not significant except for time 4. Time 4 is significant. P-value is 0.08 based on mean. So assumption for homogeneity of variances is met except for time 4. Okay, so we need to acknowledge for time 4, the variance is not equal between the group. Then another result is the box test of equality of covariance matrix. So box test p-value is significant also. So the assumption of equality for covariance is not met. So we acknowledge it as a limitation. So the best is it is met lah. If not, then it means that there might be some bias in the result of mixed ANOVA, but we acknowledge it as a limitation. So now we come to step number 4, interpretation, how to present the result in the table and conclude the result. So we need to answer 3 research questions and objective. Okay, remember the 3 research question and objective, which is the time effect in the group, whether any changes or not within the intervention and control group, and whether any difference between the 2 groups, and whether any interaction effect. This is in between groups, and then present the plot. Okay, this is the example table that you can present your result. This is the overall statistic result for time, group, and interactions. Okay, so perhaps you have more variable. In real research, normally researcher will have more than 1 variables. So you might have other variable like BMI, blood pressure level, and so on. So you can list them down in this table as well. So here the test effect is time, group, and interactions, and then you enter the F statistic value. So which F statistic value is depend on the result of your multi-test. Okay, if the multi-test is not fulfilled, then you can choose whether the multivariate test table or the within subject table. Okay, below the multi-test table. But of course, you can indicate which statistic you are reporting. So here I mentioned Elytrace statistics reported. Elytrace is under the multivariate test table. And then report the p-value, the partial eta square. Okay. So here we say that there was a significant difference of mean fitness score within group based on time. So the time effect is statistically significant, p-value is significant. And then there was a significant difference of mean fitness score between group regardless of time. So the group effect was statistically significant. So p-value is significant here. Then lastly, there was a significant difference of mean fitness score between the group with regard to time. So the interaction effect is statistically significant. Okay, so this is statistic value for all the test effect. There are 3 test effect: time, group, and interactions. And now we want to report the specific result for time effect, group effect, and interaction effect. So table 2 normally will be the comparison of fitness score within each group based on time. So you can produce table like this. You have intervention group, control group. So if you have 3 groups, then your table will be longer here. So MD is the mean difference, and then the CI is the confidence interval, and we have the p-value. So here we know that comparisons between pre-intervention versus end of first month. Okay, the difference is significant for intervention group, but for control group, there's no difference. But from pre-intervention, from baseline until end of second month, for intervention group is significant, and for control group is significant. Okay, and the rest is the same, with the same interpretations. Okay, so there was significant differences of fitness score between all pairwise comparison for intervention group. So notice that all the p-value for all the pairwise comparison is significant for intervention group. There were no significant differences of fitness score between majority of the pairwise comparison for control group. Okay, except for comparison at pre-intervention and end of second month. This one. And pre-intervention and post-intervention. And why I put post-intervention? Intervention. Yeah, That's right. Sorry. Yeah, correct. So pre-intervention and post-intervention for control group is significance. And this one, this part. Okay, so move on to the next table is the group effect table. So here we want to produce the mean difference between the intervention control group. So the mean difference is 5.38. This is a fitness score unit, and the p-value is significant. So we said that the overall mean difference between intervention and control group was 5.38 with this 95% confidence interval with significant p-value. So there is a difference between these two groups. And then next is the table to present your interaction effect value. If let's say the overall interaction effect is not significant, you no need to proceed with this comparison. So if let's say the interaction effect is significant, then you have to proceed to check the mean difference at each time point when comparing the control group and the intervention group. So at pre-interventions, okay, there is a very small difference between the control and intervention group. The difference is less than 0.001. So as I mentioned, at baseline, both groups are very similar in terms of their fitness score. Okay, so end of first month, we can see there's a difference already. The intervention group and the control group, the difference is 4.17 based on fitness score unit. Okay, and the difference becomes more obvious when come to post interventions. When the intervention ended, we can see the fitness score is obviously different between both groups. So there was no significant difference at pre-intervention between both groups. So there was significant differences between both groups at the end of first month, end of second month, and also post-intervention. So all the p-value is significant. Okay. Then we produce the plot. Okay. We come up with the plot. So we have the intervention group. We have the intervention group in green line and then the control group in the blue line. So in conclusion, the 3-month vigorous exercise program was effective in improving the fitness score among the intervention study participants. So study participants in intervention group demonstrated increasing trend. So increasing trend in fitness score from pre-intervention to post-intervention. So the increasing trend was statistically significant. So this refers to the time effect. So there was a significant group difference on fitness score after the 3 months rigorous exercise program. So this one is referred to the group effect. Then the fitness score was statistically significant difference between the both group at each time points, which is the incorrection effect. Okay, except for baseline lah. Okay. And so far, any questions? Okay, lastly, let me explain a bit what is effect size or what is eta square in repeated measure analysis. Okay, eta square or effect size or partial eta square actually, in repeated measure actually is a partial eta square lah. So this value is actually indicate the magnitude of the effect. Okay, if the effect is large, the value is large. So the value is actually range from 0 to 1. So if near to 1 means there is a very, very big, very huge effect, very huge difference. So standardized estimate of an effect size thus comparable across uptime variable measure using different units. So the eta square actually is the standardized estimate value of effect size. So it is standardized, so that's why we can compare across different outcomes if they are using different units. For example, we have different way of measure the fitness score using different units. Okay, so that's why we always have the standardized estimate value for this eta square. So how to interpret this partial eta square in our repeated measure? So if the value is 0.01 or lower, it indicates a small effect. So if the value is 0.06, it indicates a medium effect. And if the value is more than 0.14, it indicates a large effect. So this effect size is largely also depend on the field of the study. Some field of study, they want the effect size to be more than 0.3. Some just follow the reference in the literature, as I put it in here. So it depends on the field. Some field no need to report the effect size. Some field, yes, you need the effect size. Otherwise, your editor or the reviewer will require you to include the effect size or the eta square for repeated measure. Okay, that will be my last slide. Let me see whether any question remains. I'll stop sharing first, otherwise I'm not able to see the questions. Okay, I think there's no question. Oh, now it's 3:30.